Hello, can you hear me properly? Seems like yes. And now let me introduce myself and let me tell you about the content of my speech. My name is Maxim Morar. I'm the owner of the product related to containerization platform. It's a Kubernetes company, Microsoft company, and I will develop on it. And what is the goal of our presentation? We're going to deal with the microservices and containerization, and we'll talk about their value for technological companies. What are the pitfalls? What is cybernetics? And how can a reliable cybernetics may be built inside a large fintech organization? I will outline the technologies and key business values, as well as the rational use. It is based on our experience, but you may also overlap this experience onto your activities. And now let us begin. And there is also a brief spoiler. We'll have a demo. In the end, I will showcase the platform and the ways to deploy an application, which is described as a deployment manifest of container, and also going to show you the inbuilt security platform, which may be useful for DevOps team developers and the cybersecurity colleagues. Let us start with accurate figures. We have accurate figures on the annual market growth of the containerization market. It exceeds the classic virtualization figure by a factor of 3. You can see the figures of microservices and Kubernetes. 2 to 4 years ago, we used to state that Kubernetes and microservice are nothing but a trend, and now it is interwoven in our lives. And when it comes to small and medium-sized business, Kubernetes is a common way to embed microservice applications. They are applied ubiquitously. Some of the marketplace have been using it in an active way, and it's the present for them. Some of them are approaching it, and that's their future. If we're going to outperform the market speed, we should make friends with these technologies unless we achieve that. Who uses Kubernetes and microservices as part of your organization in any form? That's great. It means that you are part of this context. We've just familiarized ourselves with the figures related to the containerization of microservices technologies. And now let us take a look at the figures which are relevant for the Russian situation. That's the report on development operations DevOps condition as of 2023. This survey is conducted on an annual basis. IT leaders of large-scale organizations of the financial sector are questioned, and this bulletin is issued. Here are the four figures which are especially striking. Here are the key goals for IT managers in terms of delivery and development of software, and it is related to business demands. And they are eager to enhance the quality of the products developed. They're going to expedite the delivery of these products. It's our favorite time to market, which we keep discussing. And they're also going to cut down the costs for both development and operation. And if this is applicable for both segments, it's great. And all this revolves around the containerization technology and orchestration technology, and microservice technology as a paradigm. Our technologies are friends of ours, and they allow us to achieve these business results. And how can this be attainable? Let us dig deep into it. Since many of you are part of the context, I'm not going to dig deep into it, but we're going to synchronize and discuss these technologies. What we have: monolithic architecture. Each custom system architecture. Just imagine you have an icon of an application, a mobile app. This app contains dozens of lines of the code. Each module is functional, and it has a strong peg to the previous one. The dependence is hefty. This architecture has both benefits and drawbacks. Let us discuss the drawbacks, because it is them which contributed to microservice development as a technology. As for the first drawback, each of these components is inextricably related to the previous one. That is why it is hard for us to alter our software, because any modification will hit the previous model, and in turn will hit the previous model to etc. And that is why the release time is prolonged significantly. An organization may prepare a large-scale release for 6 months or a year, and then it may be implemented, and then it will take it 6 months to rectify the bugs and glitches. It is hard for us to deliver the value to our customers, especially to our financial organizations. You're aware of that. The competitive environment is cutthroat, and we should deliver this value as quickly as we can. We cannot scale up one module which requires more resources from our side. Be it good or bad, no matter, but it is not that lucrative. We need more resources and more servers, and there will be a downtime in the short run when we purchase them. Another problem is safety to failure. If a problem based on the code of one module arises, the whole service will break down. There are some other issues, but these three ones are fundamental. And this leads to a switch of organizations to microservice architecture. The application is decentralized into small microservices, and they carry out their minor functions. What does this enable us to achieve? Since there are lots of decentralized components, they are easily replaceable. They may be deployed at least even once a day or once an hour, but we may deploy it more promptly, and we may test some hypotheses and deliver some features to our users. That's great. As for scaling, that's another problem. We may add the resources to the component which requires instant resources. We don't have to purchase a lot of servers so that they could generate downtime. So right. The next problem is fail safety. Yes, the components are fragmented, distributed, and they're independent. Not the whole stack is applicable to the application. For instance, we discontinue 2% of the functionality, but the rest of the application is available. Let us move forward. In order to contribute to existence of this microservice, they need a shell access to the operating system, their resources, and their processes. We have microservice. We may distinguish a virtual machine, the server on the whole, or a container. Since it's a micro application in the first place, it will be creepy and ineffective to provide the whole server. That is why we provide the container. When we have a backlog of containers in an organization, we should manage them. There is a set of systems called orchestrators, and in fact, as for the standard, so the global standard, Kubernetes platform is an orchestrator, but everything is not that simple in Kubernetes platform. As a concept and as a tool, it is part of an organization, and it is redundant. It is not required by the organization. It doesn't satisfy the team's need, be it DevOps team or other teams, because this Kubernetes is to be monitored and logged somehow. This requires security in terms of banking level production. High level of security is required, as well as delivery tools, to name a few. And accordingly, we refuse this concept, meaning that we need Kubernetes. We understand that we just need a platform. How can it be assembled? It's the choice of the customer. You may either do it on your own using a lot of open sources, or you may just take out-of-the-box solutions where everything is embedded, and you may just press the button to retrieve it. Red Hat OpenShift was the solution used by a lot of banking institutions, and in fintech, Wimpertum Zoo was also applicable. But now these products are not available, as far as you know. But still, there are some alternatives. For example, we are inventing one of these alternatives. It's called Nova Platform. Let me briefly describe it. And what would I like from you? In order to make it even more valuable for you, let us move on to a dialogue, to a conversation, and it will be great. It is based on our experience and our product, and please perceive it as the approaches which may be applicable and which you may apply. And if you're going to establish everything on the basis of an open source Oh, that's all right. I always support you, and I'm going to describe our experience. Let me talk about Nova and our product team. This team is dealing with Kubernetes and all that which is related to microservices starting from 2018. So far, we have launched 35 projects. There are not many of them in terms of in quantitative terms, but there is a specificity. It is based on a very large integrator, and we launched the products for the best, for the top customers of Russia, be it banks top three banks, top three the retail companies, the key ministries of the company. Why am I enumerating them? You should realize that our experience comes from there. It originates from this sector, and some of the solutions rest on this experience. And you may trust them, and you may put them into practice. As for Nova, it's a modular program, and the kernel of this platform is Kubernetes. And as for Kubernetes, a lot of modules are supplied to it. They're so-called add-ons, and each of them have their own value. I'll develop on the product architecture, and I will tackle it more thoroughly. What's the key concept of this product? It should be installed easily and simply. It should function without a box. You should just take it and start developing it and start delivering value. We are focusing on development, revamping of the infrastructure, automation, testing processes without thinking of the intestines of Kubernetes and the integration of quite a number of components. This is an eligible scenario. This platform shouldn't be linked to any infrastructure. There shouldn't be any constraints on using it in the overt, zvirt, and other virtualization environments such as that stack. This platform ought to be compatible with all the systems, including bare metal servers and public cloud-based systems. It is of paramount importance. When it comes to these scenarios, in which cases this made this platform be useful? It's about import substitution. There was an OpenShift. Everything should be altered, and it is crystal clear. There are also microservices which may be applicable over the past year. Who has augmented the number of microservices of the organization on an exponential basis? Because this is related to you or not. As for cubes and microservices, when they appear in the organization, they are capable of incrementing rapidly. If you have a case of this kind within your company, this might be topical for you. And we're discussing it under the auspices of digital transformation and big digitalization. We experience it on a daily basis. Everything is ever changing, and we're enhancing the development. And this development needs foundation. As for microservices and containerization, this platform may be used as a foundation. There are several specific features. I'm going to tackle them, and then we will move on to a technological stack. The first one is fast deployment. The whole platform, including the component base, may be installed rapidly. It will take approximately a minute, and as for our case, it requires approximately 10 minutes. It also needs a convenient UI so that management could be convenient, and neither the developers nor the DevOps team members should suffer while installing it. And we also have a crucial specificity. It's the approach of the system as a vendor. There are a few words about us. In which directions are we moving? Our key concept is creation of an ecosystem vendor focused on IT infrastructural products. The key message is the programmably developed data center. When a company has a lot of virtualization tasks, such as billing, managing, the bases should be replaced, Citrix should be replaced. We may perform a backlog of market analysis. We may analyze 30 competitors here, then 20 competitors there, then 10 competitors over there. This may be purchased afterwards, and then it will take several years to achieve it. That's a pathway, but there is a shorter journey. We may accumulate the products which are integrated with one another. And they are kind of friended within the box. The support is clear, the release cycle is clear. This shouldn't be related to the fact that it's not on our side, it's on the virtualization side. We're moving in this direction, and that's the vendor which we are constructing, and that's the key specificity. And these products are really integrated. Many of us state that that we're truly cool, but what really matters for us is the value of this ecosystem. It shouldn't be just a cool case, it should have a tangible value. And for this reason, we are launching large-scale integrations. As for the coolest products of our portfolio, a one-third of these products are embedded, and they are fitting into building a private cloud in the organization. They have the following specificity. When you launch Nova inside our virtualization, the virtual machines are automatically deployed, and using automation, you may automatically ensure scaling and deploy more resources and machines. And as for the remote distances, an automatic state driver may be applied so that Nova can be compatible with storage presented inside the virtualization platforms. That's out of the box integration with virtualization. We also have CloudLink, which accomplishes another important function. What does it actually mean? It's a single portal which brings together diverse virtualization platforms. For instance, you have Zvirt, you have VMV, and you have another public cloud, and you're going to control that from one place, providing for end-to-end billing and a role model. And there's a particular group of solutions called cloud management platforms, and CloudLink is belonging to this group. It's kind of an umbrella which covers all of the infrastructural facilities, and you may manage it from one place, from one single place. And CloudLink is also integrated, and it may act as a single control platform. We have the team of developers, team of DevOps, and if the issuance of Kubernetes platforms is responsible for that, it will become more convenient for them to do it from one single place. What really matters, the volume and the depth of this integration is continually augmenting, and we have ambitious plans in terms of development. As for installation, this may also be projected onto your activities in accordance with your tasks and missions. We faced the following fact. What really matters is to provide a range of options to customers on the way how this platform may be installed. We need a native approach, just like Red Hat. It's about installation from public repositories. When you have an open circuit, you get access to the internet network. This is agreed upon with your cybersecurity experts. In this case, you download your utility called downstell. We feed the configuration Java file to it, IP node and their rules, and be it master of worker, and the networks are specified there. You click onto deploy function, and that is why this platform may be applicable. I also have set of customers who are going to remain in the bunker. It's a fully closed circuit. It doesn't have any windows outside. What should be done in this case? We also have a way out. In this case, we have the second approach to installation. It's called virtual appliance. It's an image of a virtual machine which weighs 40 to 50 gigabytes, and it has all the necessary packages on board. This appliance is transferred to a customer in any way, be it a link or the use of a detachable external carrier. A customer may download them as part of the data center, and this platform may be bootstrapped on their infrastructural facilities without any access to the internet. That's the ambitious and relevant mission in terms of a backlog of technological components. Some of them are sheer open source, and when it comes to pulling them into the closed circuit, it's very hard to update it on a regular basis, and that's the out-of-the-box solution. It's an ambitious goal. And now let me use the approach from the bottom to the top. No platform of this kind should be should have a pack to infrastructural facilities. When it comes to virtualization, there's only one technical constraint. It's related to a hardware platform. We're supporting x86 architecture, and that's it. It's explicit for all of you. And as for virtualization infrastructure, we may be deployed anywhere, but we support particular types of virtualization with respect to automation, which I have mentioned. For instance, Zvirt embedding. As for automatic deployment and scaling, now it is implemented in Zvirt in similar products, and the vSphere Field, auto deploy, and CSI may be performed out of the box. And obviously, other virtualization platforms are continually added. We're going to finalize the OpenStack, and we also have bases and some public clouds. We're still thinking of that. As for operating systems, we are now supporting two key branches. It's Alma-Linux and pure open source. And this Summerhill and CentOS, everything is supported. But we're also going to add Astra-Linux and Alt-Linux by the end of the year in order to satisfy the need related to 3 key operating systems in Russia. And then it will be scaled up onto other platforms if there is a request for that. And as for uptime, we use Containerd. And when it comes to plugins, we have 2 kinds of plugins on network management. The customers may select the ones with which they're eager to work, the ones to which they have got accustomed, and which plugin is custom-made with respect to their tasks. But these components are welded correctly, they are transported, and automation is performed, and it is related to a security component, and it is painted here, and I will focus on it in more detail. It is inscribed as a secret manager, but it is much larger than a classical secret manager. There's a hash port wall under the hood. Perhaps you have come across it. It is a broad-based one. It's the second core and heart of the platform. Why is that so? Apart from the basic functionality of secret keeping and confidential information, it is also used as an PTI infrastructure and expands the functionality in terms of certificate management. And it is the single center of user authentication in the platform. All the users are entering it using this platform, this module, and that's how it is embedded with external systems such as Keycloak by Microsoft. We're supporting these protocols, and then the customers may have their ID using this integration. And thanks to these technologies, the users may log in once and then jump from one system to the other one using SysO and the needed operator. As for the upper level, namely platform services, all the tools you witness in terms of monitoring and logging are out of the box, and the platform has 2 scenarios of work. First, it may be self-sufficient and independent. It should be capable of monitoring its own methods, and its metrics of monitoring and logging should be stored somehow. And all these tools are out of the box. And there's also the second scenario. You may have a centralized log storage or monitoring tool, and it is necessary to forward the metrics to it in the necessary format and not to overload the platform inside. There are some pre-configured operators inside Nova which will enable us to resolve this issue. As for security, have you ever faced the following modules, such as NoVector or Crocs of security platforms? Have you had this kind of experience? Perhaps you used to work with Red Hat or OpenShift, which is being actively used now. No, it's unparalleled experience for you. I will describe it. There is a set of solutions, such as security platforms inside containerization platforms. We have it out of the box. It's a comprehensive mechanism of cybersecurity which meets several key needs. The first key point is related to large-scale observability in terms of cybersecurity. That's about the understanding of our cluster's processes in terms of safety. Do we have any vulnerabilities in the container launched? Is this vulnerability critical or not? And there are some recommendations on redressing and eliminating them. This vector has a particular UI for management, and I'm also going to showcase it. It is also attributed to large-scale opportunities for writing their own security policies. We may use our web services to write these policies, which will limit some of our activities. It may impose a ban on launching the containers. This may be deployed, this policy may be applicable, and we will somehow abide by cybersecurity and settle this issue. And there are also a lot of opportunities on report generation. They may be uploaded, the condition may be tracked and stored somewhere. It is truly convenient and practical. As for configuration management, as for continuous delivery systems, we use Flux. Its main functions are the following ones. There are two of them. The first one is the internal task. It's about the delivery of applied software within our platform and its inner components. And as for the second approach and the second task, it is the following one. It may be applied by our customers as a classical continuous delivery tool. It may be implemented by BTOX practices and approaches harnessed by an organization, be it infrastructural management. It is stylish and trendy. I'm not going to focus on UI, I'm eager to show it to you. And that's the final point. Talking about the solutions of this kind, we always have a particular dilemma. For example, is it necessary to pay money for a commercial platform, or there is another way out? Everything may be done on your own, on the basis of components, and may a lot of open sources be implemented on your own? We may discuss it. If you would like to comment on it, I'm eager to pass the floor to you and to join the conversation. What's your vision of that? There are always advantages and disadvantages, and it is the customer who makes the decision. Here are the advantages. Everyone thinks that it is free of charge. Since the open source is gratuitous, no one will pay for the licenses, but it is conditionally gratuitous because when we implement a lot of open source technologies, it is related to our in-house expert review. We have more than 30 components of open source for one landscape and service. Which team do we need in terms of the qualitative and quantitative features? This has to function on a stable and reliable way. We should sit still without being concerned with possible accidents or failures. We need dozens of qualified experts, and we lack them right now in Russia. The number is diminishing, but there is always an option of that kind. We may deeply customize the open source, but it is also the issue of competences, of qualification, and the need. If it's our fork of our component, who will support this fork and this compatibility? That's the question. It's questionable whether it's mandatory to move in this direction. And if we reject vendor lock, that's true. On the other hand, we may move on to team lock. It means that we implement some inner features, and it has been transferred to production, and it exists in the production, and as a critical service deployed. It has been implemented by several people who have left the organization. Kubernetes and the in-house platform does not have any owner any longer. That's a deplorable case, but it's realistic. Many comrades of mine have embarked on that, and afterwards they suffered. There are some other cases related to this open source. There are no warranties, no guarantees, there is no support. If a problem arises, we should help ourselves. The problems related to the code level. We should adjust our products to ourselves. We cannot either affect the community. And there's also a specificity of this choice. As for employment and payroll, you are aware of the difficulties right now. It's very hard to employ skilled people and to pay the adequate salary to them, appropriate salary to them. That's all I would like to highlight. That's it. That's the Telegram channel where we post the news on our products. You may follow it if you're interested in the evolution of the Russian software as part of our portfolio. And that's my personal Telegram channel. If you're eager to ask me a question and if you're interested in something, please don't hesitate to ask me. And I'm eager to answer your questions and to tell you something interesting. Now I understand that I have only 15 minutes left. Let us move on to demo version. Let us start with an authorization window. I was talking about CSO, and it is visible here. That's the platform of managing our portal of managing our platform. It has two management scenarios. The first one is web, and the second one is ClickHo. It's based on an interface, and all these utilities are supported. We have significant opportunities in terms of UI. We see the depth of our cluster and its integral components. That's the memory, that's the resources. We see the number of nodes and all the necessary data about the cluster. If you see an OpenShift, if you used to see it once, you should pay attention that this interface has a strong resemblance to the OpenShift. OpenShift has an open project called OpenShift Console, and it underpins our activity because we used to deal with this tool in the past. And when the following question arose, what should underlie UI? We didn't even have any doubts. We took this product, we upgraded it and customized it to our needs. The unnecessary functions were removed and the new features which are needed by us were added. Here are great opportunities for managing our Kubernetes. Here is the functionality of our Kubernetes. We have launched some applications. We have an opportunity to launch some deployments, and we may provide for upscaling. We may just press this button this way. We may familiarize ourselves with metrics, and that's the Java editor presented in the online format. In order to make it more illustrative, we're going to deploy an application online. I have a ready-made manifest of my engineers. That's the manifest. Sorry. That's the manifest which is launching the online store of socks. Well, why not? What does it look like? I have a button here, that's the plus, which will launch my deployment manifest, which we have issued. The deployments and ingresses and services are itemized here. They are needed for the app deployment. If there is an opportunity to make it by a GIF file integration, I'm not going to torture you with this technology. That's how it may be controlled from one single space. In order to make it more enthralling, let us launch an online timer and let us take a look at the time needed for launching our cluster. Well, sorry, our online store. Let me press on the start button. Now I will move here and launch my manifest. This deployment manifest, as far as you know, is a description of the way this app should be deployed. It is Dockerized, it is in Docker pods. That's a description of the way it should be deployed inside my cluster. I click onto deploy a button, and it has used to have 404 error, and now it has 503 error because ingresses and services are not elevated any longer, they're not upgraded. But if we follow this plan, we'll have an online store one day. There is a namespace for names which is called Sock Shop in my case. Yes, definitely it is. I have this namespace, and there is now quite a number of pods here. Here are the containers launched. As far as you can see, that's the ready status. Hopefully it's clearly visible. That's out of 1 of 1. It means that pod is launched. And as for 0 out of 1, it means that we are now expecting the launch. And what's the specificity? We'll witness it. It's evident. The application is fully launched, and it will be visible as soon as all the containers are upgraded. There is a front-end container. It has already been launched, and some of the front ends should give return. It gives return somehow. But what does this front lack? It is an intrinsic feature of any online store. I mean, our goods and pricing and the opportunities of choice. Why is it happening? We have to wait and see. It needs a lot of resources and it needs a little bit more time for that. I'm not going to violate the integrity of this experiment. It should be accurate and fair and clear, and don't stare at the screen. And once we are launching the catalog, let me show it for you. And it really matters for the developers. They deploy their software in one area, and then you'll take a look at the reaction of clusters and the applications to the load, how it is managed inside Nova. What really matters is monitoring and a chance to take a look at the metrics. For example, SKU utilization. Let us take our stock online store as an example. It is launched here. That's how we're going to do it in this case, so that it could be visible more clearly. We can see the utilization for a CPU related to each and every pod, how our conditional microservice and our bot is generating the load onto our cluster. And this is also applicable to memory, to the throughput capacity of this network and disks. It's very convenient to have it in a concentrated area, but definitely this option is always remaining. Let us get back to the online store. What's happening to it? The catalog is launched. It took us 3 minutes. Let us check it. Well, that's great. Our online store is launched. We see some socks here. We can even add them to the cart, to the basket. They're not my favorite ones. They are of choice for others, but let it be. And we may also add the payment fixture. If we dig deeper into it, everything is finalized at the payment stage here. Why am I showing to you? You should see how easy it is. It takes 3 minutes and a simple deployment manifest. That's the manifest issued by the engineers, which may be disseminated to other applications. We should streamline it, elaborate on it, and upgrade it until there will be a production store. It's the line of time to market reduction. And since I have a couple of minutes more, let me show you the security point, which I have mentioned. We are also entering the inbuilt portal on the basis of NeoVector. What do we have here? I'll briefly outline it because I'm not going to lag behind. If you're interested in that, I'm going to show it to you in more detail. That's the general dashboard and the security condition of our cluster. And the worst level of security is 100, and the best level of security is almost impossible. It's practically impossible in the real pod. It is 1 in the real node, and here's a 32, which is limited. That's what I can do in order to enhance my level of security. For example, I may launch some pods with some privileges. I may impose a ban on launching the privileged pods for the account, and that's convenient. And now I'm going to describe observability. There is a Hub UI functionality. Perhaps you have come across it. This has a resemblance to it. It issues a chart of the network of internal components of our cluster. Let me show it to you. You can see the scale of it, but I will zoom it up so that this could be more visible in a particular open space. We have ingress, and as for ingress traffic, it moves to particular components. I may click onto it and show you the particular chart. HTTP is leading to a particular protocol, and I may also familiarize myself with the rules processed by this traffic, and I may also write my custom-made rules for my own tasks. Proceeding with observability, everything is split by levels. That's the platform level, namespace level, node level, and container level. As for the platform level, it is 1.26.8, and there are no vulnerabilities identified. These areas for namespaces, there are some vulnerabilities, and that's the level of the containers. Let us move on to the containers in order to focus on them. That's the most interesting one, and it has several vulnerabilities. We select a particular container, and let's take a look at its scope in terms of the vulnerabilities found. We have 4 high-level vulnerabilities and 5 medium-level vulnerabilities. Particular links to CVEs are attached here, and the versions of patches are also described here, and they are corrected here. We have CVE. It pops up when we witness this vulnerability. I press onto this button, and it is itemized on this website, and it is stated how this vulnerability is to be removed inside this cluster. It's rather convenient. If I had an external ranger, I would be able to see it and to scan it, but we lack it at this stand. Let us move forward. We also have a chance to write our custom-made rules for security. For example, that's what I mentioned. I may prohibit workload, which is launched in a particular space. I have several scenarios of functioning. It's called protect. It's a new working mode. It means that a vector blocks what is prohibited. That's the blocking mode. And I also have a monitor or audit scenario. We just observe it. We harvest data, but there are no rules or policies applicable to a specific case. And here I can enable or ban a rule and write my own one in order to let this vector process it. What else would I like to show to you? It is the general condition of vulnerabilities of our cluster. You see that there are a lot of vulnerabilities, and there is a backlog of them, and it is gaining the following level of assessment criteria. No, let's select this one. I'm not going to upload any particular record. That's how it may look like. I may show it to you. That's a compliance report. That's a report for security experts on the security cases inside our cluster. That's how it is uploaded. It is uploaded for PDF, and it may be printed out. All the data on the vulnerabilities of our clusters are listed here. I don't know whether it is legible here or not, but it is available. And this tool improves the cybersecurity expert's life. And there are some other levels, such as code analysis and code protection, and it is created by analyzers. But as pertains to our time, it may be closed by the inbuilt tools from Nova out of the box. That's all I would like to highlight. Hopefully it was interesting and enthralling and practically useful for you. And I'm eager to answer your questions if needed. If you want me to discuss it in the form of a conversation, I would also like to express my gratitude. Thank you very much. Yes, dear colleagues, if you have any questions, welcome. No questions? Well, that's it. Everything is crystal clear. Thank you very much.